Recording. Today is Thursday, the 22nd of February, 2018, on a cold, wet, rainy, nasty night in Frisco, Texas, but it is no ice. We have no ice here. And tonight we're going to do several things. I'm going to review chapter 4. There is a lecture posted last week, even though I could not be here in person. I did get a lecture out there posted somewhat. So let's review. We know how to do two kinds of table joins. We know the table join, the inner join, and the left outer join, right outer join. So when you say outer join, you typically mean either left or right. So let's talk about inner join first. If I say inner join, that means I want the records from either table that participate from both tables. They must participate in the relationship. Inner join cannot pick up childless parents, and inner join will not pick up invalid foreign keys because there's no participation in the relationship. So the inner join, you have to be in the relationship. If you're not in the relationship, it doesn't pick it up. Okay. For example, return the vendor IDs with no corresponding, let me bring that down, invoices. So this is simply not going to work as an inner join is not going to help me here. Why? Because I'm looking for something that does not participate. I don't think I have a use in here, so I don't expect this to. Okay, well, it did run, but it did not give me any vendor IDs with no. All of the vendor IDs have invoice IDs with them, because I get the pairs. In order to be in this join, it has to have the pair. It has to participate. I don't want the ones that participate. I want the ones that don't participate. Okay, and that brings us to, if I can pull this down, I guess everybody's hearing me because I don't see any messages. I want all vendor IDs. So I'm going to select the invoice ID, vendor ID from invoices I, right outer join vendors V. Now, the thing to notice here, there is a right outer join and a left outer join. One of those tables is on the right of the other one. As you read from left to right, which one is on the left and which one is on the right in this case? Okay. One on the right is the vendors. As if you were reading a line, just read it as you would normally read it. Even if it wraps around and ends up on the left, you read from left to right. So the one the farthest over is to the right. I'm going to get everything from that table, from the table where this guy points. So this gives us the pointer on it. Which direction are we talking about? And in that direction, I'm going to get everything from vendors. Isn't that what I want? I want all vendor IDs with no corresponding invoices. This is going to give me, this join will give me all of the vendors, even vendors that don't have any invoices. And the on is the same. On is just like it was in the inner join. Equals means equals. There's no difference in this line. This line you can put in any order you want. On with any way you get that equals written. It's equal one way, it's equal the other way. So it doesn't matter. It was the outer join that caused the change in the syntax. We have the old implicit syntax of the inner join, and that was standardized across all platforms. It was the outer join that gave us trouble. If I run this one, I'm going to see a little bit different output. I'm still going to see a whole bunch of them. Execute. Now notice I'm seeing, let's bring this up. Notice I'm seeing a lot of them now with nulls. Okay, so I have quite a few vendors with no invoices. Probably, I think I have more vendors with no invoices than I do vendors with invoices. And so the invoice ID is null. So I'm looking for, and I want everything from the vendors table, and right now this will not find an invalid invoice ID. I think I have one in there. I think I put an invalid invoice ID in there. Should have. But this won't find it because I'm taking everything from the vendors table. Look at the way it's pointing. Okay, point to the right. On the right side, get everybody. Now I'm going to, let's filter the ones out. I don't want to see the ones with invoices. I'm only interested in the ones without invoices. So remember, I'm in where this invoice ID is null. Select invoice ID, vendor ID, where the invoice ID is null. Do I really need to see the invoice ID anymore? It's just going to be null. All I'm going to do is see a whole bunch of nulls there, but I can do it anyway, execute, and I see all of these nulls. So I would say, why am I bothering looking at that invoice ID? If all I'm going to do is see what is that 89 or 88 rows, depending on whether you've updated or not. If you're off by one in the output, it's probably because sometimes I mess with the creation script, and I'll put some data in there, and it will cause an off by one. Don't worry about it. Your query is correct. Whether the data underneath it are correct or not, I don't know, but your query is still correct. Let's see. I could just as easily, I'm going to do a copy here, paste. I don't really want to see the invoice IDs because all I'm going to see there is null. I'm going to change this to a left outer join, and now the invoices. Let's see, I meant to do a cut there. Cut, paste, cut, paste. Now notice that they're still pointing to the vendors table. This will be exactly the same query as above, except I've just taken I've taken the invoice ID out because all I'm going to do is see nulls. So when I run him, I see 89 rows, which is the same thing I got last time. And those are the ones where it's null. If you want to see the nulls just to make sure you're getting the right one, there's nothing wrong with putting them in there. I just didn't want to see them. Okay, next question. Anybody out there in internet land wants to pose a question? I am watching my inbox, so I can see the inbox pretty easily. So if you have a question, I've got all the your microphone's muted, but I can see the inbox. Are there any invoice IDs with no corresponding terms ID? Okay. Different question. How do these relate? Let's go take a look at it. Let's see, go to View, Object Explorer. I want to see I'm going to go to Database Diagrams. This is handy to know. If it says it does not have one or more of the support objects, just say yes, you want to create them. Diagram, New Diagram, and I want to put the terms. What was my other question? I believe invoice. terms ID, believe we're like that. So let's go back. Are there any invoice IDs with no corresponding terms IDs? Let's look at this diagram. Invoice ID would be the terms ID in the invoices is a foreign key. The terms ID in the terms table is the primary key. If I have a terms ID in the invoices table that does not have a corresponding primary key in the terms table, I have inconsistent data. I have a problem. The question is, are there any? I don't recall whether I put any in there or not. I usually do. I've usually put one in there. So sometimes I will, in fact, quite often, I will go in and put one datum in there. I usually will add it after the fact. I turn off the constraints, add that one piece, and then turn them back on. So I have deliberately skewed the data or made them invalid. Okay, so let's go look at it. Are there any? Which table do I want everything from? Invoices. I want everything from the invoices. So my outer join is going to have to point to the invoices table. I chose and will generally choose, if left to my own devices, I will put the upstream table or the all table. I want everything. I will usually make my outer joins point left. Don't have to. Either way you like it. Left outer join terms. There's the on where terms ID is null. Now, execute. And invoice ID number 5. It's hard to see, I know, but the invoice ID here is number 5, and he's got a null terms ID. But do I really need to look at the terms table at all? Wait a minute, what am I saying here? Are there any invoice IDs with no corresponding terms ID? Oh, okay. That's kind of a, let me go back to, let me see if I can explain that. I kind of threw myself a curve there. I'll go back to look at this. If I go to the invoice ID, the invoices table, and always say edit the top 200 rows. Notice I have a null terms ID there. This is an orphan. Okay. I'm sorry, I thought that I was looking for invalid terms IDs. I'm going to have to rewrite that slide such that it says any orphans in there. Do I have any orphans? So basically I have a foreign key that is null. What do you call that? When you have a null foreign key, so parent-child, I have a null foreign key, that's an orphan. I don't need a join to find orphans if I'm looking at the orphan table, at the table where the orphan is. I can tell that by just looking at the field, is it null? Is what I'm pointing out here. I didn't have to do, I could find it with an outer join, yes, but I didn't need an outer join. I could have gotten that information from just that one table. I can see it right there in the table. Anytime I can just look at it easily and spot it, I don't need to do a join. I misread that slide. I did that slide, I think, last semester, and I should have said here, instead of are there any orphan invoice IDs with no, and then I need to put here IE null. So if I'm looking for null values in the invoices table, I don't need the terms table at all. I can get that from one table. This is considered to do a join when you didn't need to is considered an error in database. I pointed out a few things. I said it's not important to worry about only returning exactly what I asked for. It's not considered wrong in database to return an extra field if you wanted to do a check on it or something. If you wanted to see them all be null, that's fine. You can leave that in the query. It's not considered wrong as long as you return the information I asked for. If you want to return some more, unless I say return only those rows. Okay, if you want to add some more columns, that's your business. It would be considered wrong if you did a left outer join and you didn't need to, because that's going to cause more work for the system. Okay, here's the one I thought we were on. Are there any invoices with invalid vendor IDs? I was thinking we were asking that question. Okay, invoices, are there any? Are there any? So which table is upstream? Which table is it pointing at? Well, there's two of them there. Which one? Invoices. You agree? So we're pointing at the invoices table. And I'm looking for invalid. So I'm going to have, this is going to be a pure outer join. I have to have invoices. I have to have vendor IDs. Okay, I don't think this, I'm not going to go over this a whole lot. Basically, this is demonstrating I'm turning off the constraint. Okay, I turn off the foreign key for a minute. Let's see, what am I going to do here? I'm going to update invoices, set terms ID as -1, where invoice ID is 114. So if I execute this guy, by executing this alter table, this is how you turn off a constraint. I can turn off any constraint except a primary key. Primary key, I just have to drop it, and I can't disable it, but I can turn it off for just a minute. So if I execute that, it said yes, it worked. Now I'm going to update invoices, set the terms ID to -1 for invoice ID 114. In other words, I'm making him be invalid. Execute. And now, alter table invoice up here, it was no check, turn it off. Check constraint turns it back on. But it does not check the existing data. There is a way I can turn it back on and check the existing data. I do give it to you here. To check existing data, you would execute alter table invoices with check constraint. Looks like you're saying with check, but this extra piece says turn it on and check it. Okay, now I'm going to go in there, and I know I've got that one bogus. What is it? I have a bogus invoice ID in there. I think I have another one. Select this stuff, left outer join. Are there any invoices with invalid vendor IDs? This isn't making a whole lot of sense. I wrote this thing a long time ago. This one doesn't answer that question. This is a different question. Invalid terms IDs. Are there any invoices with invalid terms ID? That makes sense. Okay, this is what I was thinking we were asking a minute ago. I have to have both of them for this. So I'm going to select invoice ID, terms ID from invoices. I take all of them from invoices as I, left outer join terms as T, where terms ID is null. I should find this one. Okay. I did find the orphan. Notice that I found in that one, the orphan also satisfied that. So if you allow orphans, most of the time you don't. This one, when I searched for invalid terms IDs, the null terms ID came back as invalid. Okay. I could have put a condition in there that would have filtered that out. So, and the terms ID is not where T.terms ID is null and I.terms ID is not null, would have gotten rid of that orphan. Because I'm taking the terms ID from two tables. So it's okay if you come back with an orphan, because you can see the difference there. One of them is null in two of the tables. The other one has an invalid value in there. So there's an invalid value in, let's see, this is in the invoices terms ID has a -1 in it. But the T.terms ID is null. So this one where they're both null isn't invalid, but that is the invalid value. Are you with me on that? Okay. So this this particular query is also picking up orphans. It's saying, well, that's not a valid value in the parent table. That's true, it's not, because null will never match. You know, if both the parent and the child are null, there's no relationship. Let's see what else we've got in this one. I think we're about. This one, what do we have here? Select vendor ID, contract update, last name from vendors v, inner join, contract updates, vendor IDs. So this is going to show me the contacts that have been updated. So if I execute this, it's going to show me the contacts that appear in the contact updates. I'm guessing this is the old names. Okay. It's just a plain old inner join. I have a vendor ID. I can go over there and look at it in the tables. My vendor ID takes me to the vendors table. Vendor contact last name. Okay, I want to find the ones that have not been updated. Now this one's going to have to come from the vendors table, from vendors, outer join points to the vendors, and where the contact is null. This one is going to show me everybody in the vendors table that does not appear in the contact updates, and I have 114 rows. I didn't show all the names, but these are the ones that did not participate. Do we have any invalid vendors in contact updates? Okay, that one's going to point. So one of them is finding childless parents. The other one is finding invalid children. Invalid vendors in contact updates. Now this one I'm going to have to point to contact updates, because this is the one where I want, I've got some invalid data in there, or I might have some invalid data in there. And this is something you'll do a lot when you're trying to troubleshoot a database. You say, well, is it all valid? So I'm going to run a lot of these queries against it, check everything. So as I'm going through there and diagramming it and figuring out what table references what, I'm going to run these queries and say, do I have any bad data in there? Do I have any invalid vendors? In other words, somebody has been updated that isn't, and so I need everything from contact updates. Right outer join points to contact updates, vendors. The on is the same, where the V, where the left side is null. So generally speaking, when I'm looking for something, if I'm looking for childless parents or I'm looking for bogus children, there are two of the big ones that you do with outer join: childless parents and bogus children, particularly bogus children, because that's a bigger problem than a childless parent. Basically, I can't put a constraint on a database that says all parents must have children. If you think about it, that would be impossible to do. Why? The parent has to be in the database before the child can. As soon as I put a parent in the database, when I say, okay, make that happen, I've got a childless parent for a second or so until I can put in the child. So it would not be possible to constrain against childless parents. You got to have the parent before you can have the child. But if I'm searching for either one of them, from which table am I searching? The join points to that table. So if I want a childless parents, the join points to the parent table, where the join field in the child is null. If I want to find invalid children, the join points to the invalid children, where the parent join field is null. So the is null will always be backwards from which direction the thing's pointing. Let's look at this one. From vendors, right outer join contact updates, and notice there's the right pointing to contact updates, where the vendor is null. Let's run him and see if there are any. Execute. I believe there's one. There he is. His vendor ID is -1, and his name is Bogus Bob. And so if you were to go look at contact updates. Now notice when we did that inner join, we didn't find him. We had to find him with the outer join. Questions? Any right join? I'm calling him a right join. I should have said right outer join, because I'm yelling at you for saying right join. I better not. So I'm fussy about syntax. There's no people will just say right join and left join. Yes, books will say it. Textbooks will say it. You'll see it all over the internet. You are encouraged to go to Google and other and check. You'll see it. It'll just say right join, and it'll also say table A join table B. Well, that's an inner join, and there's nothing particularly wrong with it. I'm just teaching this class. I want us to do it all the same way. And then afterwards, there's no reason you can't just say right join. Except I'll get even if you do. Oh, let's see. And so here I'm demonstrating. All I did was change where it's pointing. It's pointing to the table from which I want to get all of the data. And where it is null points to the other one. So all I did with this one was switch the order of the tables, and then change the left outer join to a right outer, vice versa, right to a left. And you can always do that. Many platforms, they're getting few, but at first there were a lot of platforms that didn't even give you a right outer join. It was just outer join, and it was always left. Nowadays, I don't think there are any of those left around, remaining. And that's it for this slide. Questions? I will republish this slide. I'm going to say, save him. Let's see what else we have. By the way, these diagrams are handy. Did you follow how I was doing that diagram? Let me close this. When you're done with the diagram, you don't have to save it. You just close it, and it will ask you, do you want to save it? All it is a graphic. You can save it if you want to. I usually just create them when I need them, and I don't save them. But the way you do it is first thing, I go to my Object Explorer, this guy, and I ask, what tables am I curious about? I'm curious about the relationship between the GL accounts, general ledger accounts, and the invoice line items. Let's say, how are they related? So I'm going to go to my database diagrams, right click, new diagram. I want to see the GL accounts, and I want to see the invoice line items. Here's where it's nice, account number. And I can see there graphically how they are related. Now, I don't know whether this will let me. Yes, look, it says I can delete the relationship, okay? I suggest you not do that. This is a class in SQL. Back in that last slide, I told you how to turn off the foreign key relationship and still leave it in the database. It'll still be there, but you just turn it off so the data coming in aren't checked anymore. Then you can turn it back on. That's a safer way to do it. This class really isn't about using the graphical user interface, but most anything I do with SQL, I can also do in the GUI, the graphical user interface. I can create tables over here. I think I can create these relationships. I think I can drag and drop and create a relationship here, but that's not what this class is about. When I'm done with him, I just throw him away. Do you want to save him? No, all it is saving the graphic. No, I don't want to save it. Remember talking about the this isn't in the book, and it's not something that I usually do. It is something I usually do in this class. I show you how to turn a constraint on and off. And this applies to any, this is why we name the constraints, because if I've got it named, I can go over to my SQL by which I created the tables, find the name of the constraint, and I can just turn it off. And that's fine. In fact, I will typically put not null on almost everything. When I build a table, it is not null. They call me the not null kid. Every single field in that table is constrained against not null. And sometimes I find that to be a pain in the neck, right? So my users come back and they say, hey, look, we don't have phone numbers for a lot of these people, and you're forcing us to make them not null, and or something. They'll complain. So I'll go in and I'll just no check the constraint. In other words, it's still there, but I just turned it off. I think this is a good way to do it, rather than deleting it from the graphical user interface. I like this. This is stronger. If I want to turn it back on, well, no check turns it off. Check turns it on. If I want to turn it back on and check existing data, alter table invoices with check. Check constraint. Make sure that existing data conform. That's usually a little harder. Okay. And let's see. I'm ready to. Did I save? By the way, in this, when I say edit top 200 rows of invoices, I can add rows here. Are we at a time for a break? No, not yet. I thought you might be telling me it was break time. I can add rows here. I can modify rows. If I change stuff, it changes in the database. I can add rows, and you're free to do that. If you want to test something, and you want to say, well, let's see, how could I find out if this query is working or not? Put some data in there that are defined, and it's yours to use. All you have to do is run that create SQL script, create AP, and it puts all the data back. Okay. Questions? I don't see any questions in my inbox. If any of my good number of people out there in internet land, if you have a question, you can send it to the inbox, and I'm watching the inbox carefully. So I see I have quite a few listeners. Okay, one thing I did not cover, and it is not particularly useful in my opinion. Most databases provide you with an inner join, a left outer join, and a right outer join. SQL Server and a few others, Oracle for example, also provide you with something called a full outer join. It's getting to be used. Now, what do you think a full outer join would do? It gives me everything from both tables. Well, it usually isn't very useful. Let's consider the vendors without any invoices. In other words, this is a childless parent query. Find vendor IDs from left outer join invoices. I'm pointing at the vendors, and where the invoices is null. So this will give me childless parent. I think I have about 60 of them in there. I ran it once before. This next one says invoices with invalid vendors. I'm going to have one of these in there. This is really more problematic because if I have an invoice with an invalid vendor, that means I have an invalid child. I have a child referencing something that isn't in the parent table, and this is bad. If I execute him, I find I do have one. The vendor ID 999 is invalid in the invoices table. So I can get the childless parents, and I can get the invalid children. Okay, let's see them all. Select vendor ID from vendors, invoices vendor ID from vendors as V, full outer join. Full outer join means take them both. Okay. So this is going to show me everything from both tables. If I left it, if I didn't put the where the vendor ID is null, or the vendor ID from the invoices is null. So where either of them is null. Now, I guess this is, notice that I got 90 rows. And as I scroll down through it, I see lots of nulls, lots of nulls, lots of nulls. What are those? Those are my childless parents. So we see all these guys, those are childless parents. No, because the second one is, I wish it would say I.vendor ID. I guess I should put an as on there and name them something different. Childless parent, and notice right here at the very bottom, on line 90, I have the invalid child in there also. I typically, what do I want you to be able to do? I want you to be able to use an inner join and an outer join effectively. Okay, you have two kinds of outer join, left and right, but there's really only one. There's an upstream table and a downstream table. And you either want, the upstream table is the one, what I call an upstream, is the one you're taking everything from. So I want all vendors with no invoices. A childless parent query. Pointed at the vendors, the null comes from the child, from the invoices table. Find invalid children, much worse situation. So I'm usually looking for that because that's what I need to fix. Pointed at the child, pointed at invoices, and put the null onto the parent table. That's going to show you your problem children, because when you have invalid references in there, and people will do that, particularly if you get a database that is created by someone that really didn't know what they were doing, and they will forget to put that, or they won't put that constraint on there correctly, and then somebody will fat finger the foreign key. Now you have an invalid child in there. When you come in and try to fix it, you've got to find those invalid children before you can add the constraint. That's your first thing to fix. What do you do when you find an invalid child? What are my options? Okay, well, yeah, that's the one I like the best. Option one is delete it. That's drastic. I don't want to delete records. Okay, option two, if I can, set that field to null. Okay. Do I have orphans? I don't like orphans. I prefer not to do that, but that's less drastic than deleting them. And then third is attach it to a parent. Insert a parent into the parent table. So I would insert, if I had an invalid vendor ID in the invoices table, I would insert a vendor named parent of orphans or parent of bogus data. Anybody, this is the parent of anything I don't know what to do with. Make him be -13 or something weird. I hope I can do that. Find a value that I can put in there as the primary key of that parent of bad data, and then insert him, and then change all of those invalid records to point to that parent. Now, at least I've got them. I can find them again. I don't know what they used to point to. I might make a record off to the side and keep a copy of them in their original state. But I don't know what to do with them, so I don't want to delete them. I could take them out of the database and copy them over to another one, but using pure SQL, I would prefer to just put some record over here that caught them. I don't use a full outer join very much. I'm not going to ask you about a full outer join just because they're not used a whole lot. There's a reason that's coming up in a minute. Okay. Let's talk about an onion, a union. Another option for the full outer join. Let's see. I'm going to go over to Canvas. I think I pushed this one off and have it in the next. Yeah, I have this one in module 7. Okay, we left some unfinished business. This comes from chapter 4 and the set operations. The set operations are essentially union, intersect, and what they call here except. It's basically set difference. Have you heard of these words before? A union of two sets. From algebra, yes. Database is based on set theory. And these guys are pretty important, even though this is how we build everything out of all of our logic comes from these 3 basic fundamental operators. What you'll find in algebra, in your math text, it starts talking about the idea of a set. But nobody ever knows what a set is, or it never defines a set. It just assumes, well, everybody knows what it is, and then it makes the bigger assumption that it means the same thing to everybody. But if you think of a set of numbers or a set of anything, numbers are just good as anything else. Something is either in the set or it isn't. And there are no duplicates in the set. So it sounds a little bit like we have database coming up here pretty quickly. So a table is a set. If we talk about the union of 2 sets, what are we talking about? Anything that is in either table A or table B or both. Now, it will appear in the union only once, but it could be in both tables. So if one table has the numbers 1, 2, 3, and the other table and the other set is the set of numbers 3, 4, 5, what is the union of set A and set B? 1, 2, 3, 4, 5. 3 doesn't appear twice. Okay. Now, what's the intersection? The intersection is that which appears in both tables. So 1, 2, 3 intersect 3, 4, 5. What appears in the intersection? You're correct, only 3. Okay. And the difference, I want everything that's in one table that is not in the other one. And lots of times that's a minus sign in there. So think difference, think minus. Subtraction. So if table A is 1, 2, 3 minus table B 3, 4, 5, what is in that difference, that except? Everything 1 and 2. 3, because 3 appears in the other table, it's not in 1 and 2. You usually union and intersect are used a lot more. Union operation combines 2 or more select statements into a single result set. I don't really need to read this to you, but I took a lot of trouble writing it, where the values come from both sides, either A or B. So union, think or. It's in table A or table B. By default, a union does not give you duplicate rows. You can ask it to give you duplicate rows. It will do it if you say to. By default, it does not. That's typically what you want. If duplicates are desired, you can say union all, but you almost never do. Okay, some points about union and the rest of them. It's typically 2 select statements. So if I say select something from a table, union, another select statement, I'm going to get, it's a way of putting together 2 select statements where I just get 1 table of output. I'll show you that in just a minute. The field list in both select statements must contain the same number of values. Okay. Let's look at an example. Get a new query. select vendor ID from vendors. Need to get that. Union. I'll typically show what I'm trying to do with the indenting. I will either indent the union or I'll indent the rest of it, just whatever's easiest. I like to indent to show that union. I don't like it all lining up there on the side. Now, what am I going to get here? I'm going to get the vendor IDs and the invoice IDs in one set of output. Now, I don't have an order by on here. When I execute, notice I got 123 rows. Let's see. I can't easily see what's a vendor ID and what's an invoice ID. I think I'm getting a lot of duplicates. So let's see. How would I get it? Let's see. See if I can come up with a, let's see, vendors. Let's see, I'm going to take the vendor name. What do I have in the invoices? I'm going to take the vendor name and the invoice number. Now the invoice number is a varchar 50 and the vendor name is a varchar 50. That's what I'm looking for. Notice that, okay, I'll come back to that. Vendor name. And what else? And the invoice number. Now, both of these things are the same data type. I have the same number of values on the two select lines. That's important. You must have the same number of values. Okay, I can't union something that selects 2 values with something that selects 3 values. It's not going to work. I can't union 2 values that are incompatible. If one of them is a character data, the other one has to be character data. Now, if they're both some kind of number, they will usually work. If I run this, it's going to give me some strange looking output. Notice here I got 236 rows. So my vendor name, notice it picks up the column name is the same as the first one. So it's showing vendor name. Doesn't show invoice number. If I switch these around, it would show me invoice number. And I think when I get down there, now I'm starting to see the names down there in this. So this is kind of meaningless. I don't know why it put the vendor names at the end. It didn't. It's just kind of giving them to me as a hodgepodge. But it basically put them on. If I put an order by on here, the order by would apply to all of the output. I could put an order by here, but I don't think that would, I'm not sure that would do anything. Basically a union takes anything. Now, think about a union and a full outer join. What is a full outer join? A full outer join is of table A, full outer join table B is table A, left outer join table B, union table A, right outer join table B. A full outer join is a union. I don't have to have a full outer join. I can use the union to create a full outer join. And I believe we are about at a break time. Okay. I'm going to pause the recording. Okay, I'm back from the short break. During the break, we discussed the test, so I guess I need to reiterate that for the recording. The test will be, excuse me, first of all, the practice, I got the hiccups tonight. The practice test will remain open until next Thursday, I believe. Next Thursday, I know. I'm going to leave. I'm going to go change it. It is set to time off tomorrow, but I'm going to leave it open a little bit longer. The test will be on. Test will become open on Thursday evening during class, during the lab time for class. So about 7:30, 8 o'clock, the test one will come open. Test one will be open for a period of time such that that period of time spans a Sunday. I believe I will probably go till Monday morning. Sounds reasonable. So Thursday, that gives you Thursday, Friday, Saturday, and Sunday. So that's 3 days. That's 72 hours, at least, in which to get done. That spans a weekend. If there's any problems with that, you can send me a Canvas message. Somewhere here. And let's see, the test will be, you may use your textbook on the test, you may use your notes. The only restriction is that you must do your own work. Test will consist of mainly creating tables using SQL, creating a foreign key. We'll have inner join and outer join. You will need to be able to tell the difference of when to use what. I'm not going to tell you use an inner join on this, but there will be some language in there that I want all records all pairs of records, all parents paired with their children. If a parent doesn't have any children, they're not going to appear in that output. That's an inner join. I want all parents who do not have children. That's an outer join. I want all children with invalid parents. That's also an outer join. And finally, I want all orphans. Does not require a join at all. I can get that from one table. All I have to do is look at the child table where that foreign key is null. Okay. And so I would expect you to know the difference and to understand. I'm going for an understanding of what is a join. Okay. If there's questions, you can send them on the inbox to the people on the let's go over here. Here's a full outer join. This particular example, I believe I sent this to you. There's the full outer join. Another is I can do it with a union. It is a left join, union, same thing as I'm using a left join on both of them, but notice that I've switched the vendors and the invoices. So this one has invoices, left outer join vendors. This one has vendors, left outer join invoices, and they're unioned. So that gives me a full outer join. if I were to run this, I would see the same thing as I got with the full outer join. Intersect, give me that which is in both tables, both output. So invoice ID, invoices, select invoice ID from invoice archive. This is going to show me the invoice IDs that are in both the invoices table and the invoice archive. There's only one of them, 37. I don't think they're supposed to be in both of them. I had to go put that one in there. Oh, yeah, you probably just didn't change it. I said I just had to go put that one in there.
Oh, okay. Is that in the script?
I think I put it in there manually. Go in there, and anytime you want to test it, go in there and check it. Go look at your table, edit it, put something in there that you should be able to find. Set differences. I want to find everything that's in the invoice ID, but not in the invoice archive. So in this one, if I were to run this set difference, I would not see that 37 in the output. I would see all the rest of the invoice ID, but not number 37. So this one is not going to appear. I've got order by invoice ID. Let's find out if I execute him. When I get down to 36, then it goes to 38. So 37 does not appear. In other words, everything that's in the first table and not in the second table. I don't usually make a big deal out of union. I want you to know about what is a union, what is an intersection, what is a difference. Later, there are kind of specialized things that will help you solve some problems that will come up in programming. Right now, I can't come up with a real good question that would except what is an if I give you two sets, what is the union? That which is in both of them. What is intersection? That is that which union, that which is in either one of them. Intersect, that which is in both of them. Difference, that which is in one and not in the other. And then be aware of those constraints that both of them, that's usually from two select statements or unioned. It must have the same number of return values. Both of the select statements that are creating a union, intersect, or difference must return the same number of values, and the types must be compatible. Usually you can get away if one of them is a varchar 9 and one of them is a varchar 10. It usually won't give you a problem. One of them could probably be char 10. The other one, varchar, would probably be okay. It would probably just push the smaller one out to fill out the bigger one.
That's
all three of them. Mm-hmm. The names of the columns will be taken from the first one that was encountered. So, just a minute, I'm going to sneeze. No, I'm not. I changed my mind. Okay, enough of that. Questions? Okay, I'm going to step on to Chapter 5. Chapter 5 will not appear on Test 1. So I'm now stepping into, this is Chapter 5. I am now in Module 7. I usually do not put union and intersect on Test 1 because it comes in the modules. The test comes before I talk about that, but I might put, they might be on there. I might ask you, what is a union? What is an intersect? Yes, that would be a fair question. Okay. Chapter 5, the first thing we're going to talk about, in Chapter 5 is what we call the aggregate functions. Aggregate. In other words, it adds up stuff. Okay, select, and there are 5 of them that are, we will use 1, 2, 3, 4, 5, and count 5, yeah. So 5 of them. So sum, add them up. So it takes a whole bunch of rows, adds them up, crunches them into one row. So if I were to say select sum invoice total as sum of totals, if I were to run this, I get, pardon me, I knew I was going to sneeze a minute ago. I get some big number there, 214,290.51. That's what they all add up to be. So invoices, if you add them all up, this is what you get. Okay, sum. There's 5 of them that we're going to consider. There's actually quite a few more, but 5 of them are typically the ones that you find in the textbooks. And they're we have mean and median, mode, standard deviation, variance, and all that is in there also. But these 5 are what we're going to talk about. AVG, what is that? That is the average. What is the average of invoices? When I execute it, I see that the average invoice is $1,879.74. Notice that money is presented to you in 4 decimal places. Okay, also I have minimum. What is the least? What is the maximum? So I can get what is the smallest one. Smallest one is $6. What is the largest one? Largest one is $37,966.19. And last one is select count. How many payment dates do I have in here? Count payment date as count of dates. And when I execute, I see I have 102 payment dates. And now this does not count nulls. Okay. So nulls give us a problem sometimes in aggregate functions, because what happens if I try to take an average and all I have are nulls in there? Since count doesn't count the null, what will it do? What will it give me as the average if I try to take an average of nothing? Well, yeah, but it can't give me nothing. It's got to be something. Everything's got to be something. It gives you an error message. It typically gives you a what they call NaN. It used to be it would crash. It used to be if you tried to divide by 0, your system would crash. But essentially, we're dividing by 0. Because what is the count? If you don't have anything to count, that's fairly easy. That's 0. How many do you have if you don't have any? That's 0. The problem is, what is the sum if you don't have any to add up? What is the sum of no numbers at all? Well, it's not 0 because you don't have any numbers. Now, if you want to talk about counting something that you don't have, I can count. How many elephants are in this room? 0. But I can't talk about adding up their weights or something like that because there aren't any. So the weights of the elephants aren't 0 because that would imply we had some, and we don't. So it used to be that would crash, but nowadays, if you try to take an average and all you have is nulls, it gives you back an error code, which is typically called NaN, not a number. Better than crashing. So this only counts null. Now, when you're trying to count things that are null, select count payment date as count of dates from invoices where payment date is null. That's not going to work. Okay. This one is, what will this do? If I try to execute, I get back 0 because I'm counting something that doesn't. How many of these things do you have that don't exist? Okay, well, 0. Yeah, that's fine. And so that when you count them, they're 0. Now, I'd have a problem if I were trying to add them up, but I don't. Now, so I do have some in there. This will work, though. Count the invoice ID where payment date is null, because I know I've got an invoice ID. Why? Because invoice ID is the primary key. So therefore, when I run this, it will work. And it says I have 12 null payment dates in mine. Don't know about yours. Okay. Now, I'm going to point one other thing out. This is better. I'm saying that there's very little that you can do to hurt or help SQL, but this is one of those things that you can do. SQL, if you say it wants to count the invoice ID, it's going to go in and it's going to look for the invoice ID. It's a little bit like if you've got somebody counting people in a room, and I say, let's count the people in the room. And okay, I want you to count the noses, please. And so the kid goes around and but you have your back to him. So he has to go around in front of you to count your nose, right? Because he can't see your nose. So he has to go around and get where he can see it. Each person, I have to see the nose. If I'd say count the noses, so count the ears and divide by 2, whatever. On the other hand, if you just say select count star, in this case, it means anything. If you have a record there, it counts. It doesn't matter whether it has a null field in it or not. It's just if there's a record there. Of course, if it's all null, you don't have a record. But if you have a record, it counts. Okay. Now it doesn't have to go back in. The first one would work. If I say count the invoice IDs, I'm guaranteed that that is the same as the number of records since it's a primary key. But this can run faster because it doesn't have to go in and check to see if it has an invoice ID. You with me? So you use count star when you want to when I'm interested in counting the records. Okay. This is an error. I want to see something else. Now, notice how I get this error. I've got I'm summing something, invoice total, and I have something else that is not an aggregate. Now, remember what that sum does. It squashes a whole bunch of rows into one. But what about the other one? The invoice total is going to be multiple rows. What am I going to show you for the sum? This will give me an error. Trust me on it. I will. I don't think I'm going to run it just to let you see an error. New rule. Who's that guy that does the new rules? What's that idiot's name, the comedian? He's got a joke line that says, new rule. New rule. If you have an aggregate function, what are the aggregate functions that we know about? Sum, average, min and max, and count. Okay? If you have one of those, or one or more of those, doesn't have to be one. If you have any of them in the select clause, then any field not in an aggregate function must be a group by. What's a group by? I'm going to get there. That's the rule, though. If you have an aggregate function, any of them, and you have anything that is not an aggregate function. This is an example. This is an aggregate function. This is not. Therefore, this must be a group by. And here comes a group by. I added an order by here. Select vendor ID. Okay, well, here's this does the same thing anyway. No, it doesn't do the same thing, but it demonstrates the problem. Notice that I have a something that is not aggregated. Not an aggregate. I want to see the vendor IDs. Sum, add up the invoice total. I'm doing some counting. I must group by it's usually one, can be more than one. I must group by anything that is not an aggregate. Now, this typically gives students some problems, okay? And there's no particular reason for it to. Think about it. What am I wanting to see? I want to see the sum and the count, how many total, and I want them broken out, grouped by vendor ID. So if I'm talking about vendor ID 1, from the invoices table, I want everybody, all of this stuff from vendor ID 1, I want it to be collapsed into one row. So I'm only going to see vendor ID 1 happen once. So for each one of those guys, I'm going to have one vendor ID, and I'm going to see the aggregate totals for that vendor ID. Are you with me? Let's run it, and maybe it'll become execute. Let me see. Copy with it. What's up?
Quick question. So the more just be a practice test, right? Not an actual test?
Practice test. I'm going to open that up. If you'll check the recording, check the recording for today. I'm talking about when the test is. It's going to be it's going to start at this time next week.
Okay. Yeah, I'm gonna be in class tomorrow. So.
Okay.
Yeah.
I'm talking. Check the recording, and I'll see you at Spring Creek then. Okay, that's fine. Let me get. I was going to drop this into Excel. Let's see if I can blow this up. Notice we're ordering by vendor ID back here. So order by vendor ID, grouping by vendor ID. So notice in our output where we have vendor ID appears only once, but notice that I have 47 invoices for vendor ID 123 for a total of $4,378. I have 9 invoices for vendor ID 122 for a bigger total. 110. I've only got 5 invoices, but they're big ones, I guess. A lot of them I only have one ones. There's 6 invoices for vendor ID 95. So for each, when I said the group by, as soon as I said group by vendor ID, every time the vendor ID invoice due date, okay, here we go. Let's go back up here. Here, what about group by vendor ID? And every time the vendor ID changed, I reset all the totals, totaled by that. Could have ordered by anything. The order by doesn't count, but the group by does. So group by, new rule. What's the new rule? When does this new rule come into effect? When you have at least two, I have an aggregate function, at least one aggregate function, and I have at least one field that is not aggregated. So if I say, show me the employee number and the sum of something and count something else, I have to group by the employee number. So if I have anything that is not aggregated and I have an aggregate, I must group by that thing that is not aggregate.
The third column there on that first one says 2, and you said
Here?
invoice. No, in the results down at the bottom. So you got vendor 34. I understand the aggregate. I'm really confused on the.
Okay, count. It says in vendor ID,
Is that truly two invoices?
vendor ID, let's see, well, vendor ID 34. I'm pulling them from invoices. I'm getting the vendor ID from invoices. So I have two records in the invoices table such that the vendor IDs match. So there's two invoices, but I have two invoices in the invoices table for vendor ID 34. Well, it can be. I have three invoices for vendor ID 37. So if I were to go over there to that invoices table and start counting them, I would find them. What would I find? I've got 47 invoices for 123. If I were to go count them, I'd find 47 invoices that match that 123. I'm not going to bother with it. Okay. I guess I want to talk about the count of vendors. Okay, count of invoices then. Okay. Well, I've been asked to change this from count of vendors to count of invoices. Okay. Well, if it, if it works, change it. I mean, from invoices. So this is the count. Now, notice that anytime I have a field that I have derived, and we saw this back when we first did the select, I said if you derive a field, you must rename it. If you have an aggregate function, you must give it a name. For example, sum invoice total as must have an as. I typically don't change names of fields unless I have to give them a name. So most of the time when you'll see me use an as, that's because I have to. No, it would give you no column name. You'd have an anonymous column. Commented out here on this one. If you comment the last one, if you try the first one, yes, you will get an error. But this one, I will just get the name, no column name on it there. So it's just saying no column name. And this, we don't like this. We don't like having something there that has no name. I don't mind taking the name from the database, but if it's just going to say you don't have a name. If you go to Oracle with this, it will give it the name count, parentheses, star, close parentheses, which isn't any better in my opinion. Another example using an inner join. What are we selecting here? Notice that I have a vendor ID, non-aggregate, and I have at least one aggregate. What do I have to have in this query? Got to have the group by vendor ID. If you don't have that, it's not going to run. And what am I doing here? I'm joining the invoices. Where vendor, notice, here's the reason I have to have, I'm going, why on earth did I have to have an inner join here? Because I only want to see output from the state of California. Where is California? It's on the West Coast. No, where is the vendor state located? It's in the vendors table. Everything I'm selecting, all of these selections come only from the invoices table. But once I say I only want to see California, now I've got an inner join. So I have to inner join vendors, the where clause, where the state is California, group by vendor ID, order by vendor ID. Let's see, what do I have here? I'm getting much fewer. Anyway, I got 21 rows on that one. And I could put I could put Texas in there. I think I put one in there from Texas. Let's see, did I? Yeah, there's a Texan in there. 83. Yours may be different because I have been known to mess with my data. Just because I want to see it do something different. I want to check. It's okay. It's fine. But no, by the way, you don't have to go fix it before you turn it in because I'll never know it. If you change your data, it doesn't mean anything to me. I'm not grading your data. I check it against my data. My data might be something totally different. Okay. I think I'm going to wrap up there. We're right here on an important concept. I'm going to come back to this. So I think I'm going to pause the break for the evening here. You can read this and see if you can figure it out. Notice that I've added something to it, group by having. Let me talk just really briefly about that. Having is like the where. Think of having as a where. Most of the time when I say group by and a having, I will usually put it on the same row. If it gets too long, I will indent it, showing that it is the same line. I will usually put it on the same line. Now, it doesn't have to go on the same line. Somebody else might do it differently, but I will typically put them together. They come in this order, group by having, like that. Now the where, so this is the order. Select from where, then the group by. I think of having as being a part of the group by line, and then the order by. So this is the full ordering of a SQL statement. Now, where, the where clause is something that's true or false. Vendor state is equal to CA. This applies to an individual record. Where applies to individual records. Having applies to the group. I'm going to come back to that. But you don't have to worry about that for the test. Okay, the test will proceed over chapters 1 through 4, or let's say modules. What module was that? We'll cover modules 1 through 6. It might have a question on there about union, intersect, or difference, but since I haven't done a whole lot with that, it won't be a real involved one. Practice test 1, I'm going to edit it and make it due at the end of the week. So I'll do that as soon as I stop the recording. Are there any other questions? Okay, ladies and gentlemen out there, are there anything else I need to cover? Renee, is that you talking?
Hi, I have a question about, like, on the practice test where we are choosing what database to use. When we turn this in, is it going to have to use the database that we use as a group, or does it still use the one?
Let me see if I can get that question. Does it, generally speaking, you would go use your own database. Are you creating a table?
Yes.
Yeah, use your own database.
Okay.
I'm not going to be real fussy about that, but generally speaking, if it goes to invoices or vendors or something like that, that's AP, that's the accounts payable. The others are, the rest of it's always using your own database. Cool?
Yes, thank you.
Others? Okay, I'm going to take off my headset and I'm going to stop the recording now.